Dread it. Run from it. Destiny still arrives.
Today we're going to look at the derivatives of four common functions: sine of x, cosine of x, e to the x power, and the natural log of x. I will ask that you memorize the derivatives to these four functions. We're not going to go through the proofs as to why the derivatives are like they are for these. If you are interested in the proofs, there's lots of information and resources available online where you can find out why the derivative of sine of x is what it is, and so on. But I'm just asking you to know what the derivatives are and then be able to use them. The first one is the derivative of sine of x, and we write d over dx sine of x to show we want to take the derivative of sine of x. The derivative of sine of x is simple to remember. It's just cosine x. The next one is d over dx, means take the derivative of cosine x. The derivative of cosine x is negative sine of x. The third one is d over dx e to the x power. And this one's quite interesting because the derivative of e to the x power is e to the x power. The last one is the derivative of natural log of x, which equals 1 over x. Now let's take a look at some examples of problems that you'll see with these derivatives. The first one says f of x equals 2 sine x plus 3 cosine x, and f prime of x, or the derivative, is equal to what? So when you're taking the derivatives of these, if you see a constant out front, that's not going to change the derivative at all. In fact, it just remains in place. So the derivative of 2 sine x is just 2. And then sine x, the derivative of that is cosine x. So we'll put 2 cosine x. And then, plus 3 times the derivative of cosine x. That's negative sine x. And looks like we're going to need to simplify this one a little bit, since we did change from positive to negative here. Our final answer says our derivative is 2 cosine x minus 3 sine x. In our second example, we have f of x equals negative natural log x minus e to the x. Our derivative, f prime of x, will be negative the derivative of natural log x, which is 1 over x, minus the derivative of e to the x, which is e to the x. We'll simplify this in our last line here, being very careful with negative signs. So we have negative 1 over x minus e to the x is our derivative. Let's take a look at a third example. It says f of x is equal to 6 times e to the x power minus cosine x. The derivative will be equal to 6 times the derivative of e to the x, which is e to the x, minus the derivative of cosine x, which is negative sine of x. Simplify this in the last step. Say the derivative is equal to 6 e to the x plus sine x. Let's look at 3 more examples of this. The first one is f of x equals 2 cosine x plus e to the x, and it says what is f prime of 3? Let's go ahead and solve that by first taking the derivative f prime of x. We know that's equal to 2 times the derivative of cosine x, which is negative sine x, plus the derivative of e to the x, which is e to the x. So we could rearrange this as negative 2 sine x plus e to the x. There's really no need to do that here, since we're just going to get our answer as f prime of 3 is 2, or here's where I'll rearrange it, is negative 2 times sine of 3 plus e to the third power. And this would be our answer. We'd get negative 2 times sine of 3 plus e to the third power, and we'd calculate that using a calculator in radian mode, and this comes out to 19.803. However, this is just an approximation. This is a more exact answer, but depending on what program we're using, Math Excel or Khan Academy, it might ask for one or the other, either the approximation or the exact answer over here. All right, number 5, we have negative 5 times natural log x minus sine x. So what is f prime of pi? So first we'll find f prime of x, and we'll say that f prime of x is equal to negative 5 times the derivative of natural log of x, that's 1 over x, minus the derivative of sine x, which is cosine x. Then we'll evaluate this at pi, and we'll get negative 5 divided by pi minus cosine of pi. We could evaluate this with the calculator to get a decimal answer, but we're just going to go ahead and leave it like this. Negative 5 divided by pi minus cosine pi. Our last question says d over dx, 12 e to the x minus cosine x. And we're just going to take the derivative of each one individually because d over dx says, hey, what's the derivative of these two? So we'll get 12 e to the x, remember e to the x stays the same in this case, minus the derivative of cosine x, which is negative sine x. So our final answer will be 12 e to the x plus sine x. Our final question says, what is the equation of the tangent line to f of x equals 3 times cosine x at the point where x is equal to 2 pi? In order to get the equation of the tangent line, we're going to need a couple of things. We need a slope at x equals 2 pi, and then we'll also need a point on the graph where x is equal to 2 pi. We usually do that one first, so we'll usually do f of 2 pi to get our ordered pair that we'll use for the equation of the line first. We usually do this part first. So at 2 pi, the graph is at 3 times cosine 2 pi. Cosine of 2 pi is 1, either using a calculator or remembering your trig. So 3 times 1, which is equal to 3. So we'll use this point, 2 pi, comma, 3, as our ordered pair. Then we'll need to find the slope at x equals 2 pi. So we'll do f prime of x is equal to 3 times the derivative of cosine of x, which is negative sine x. Rearranging this to get negative 3 sine x. Then we'll plug in 2 pi to find the slope of the function at 2 pi. So we're going to do negative 3 times sine 2 pi to find the slope at 2 pi. Sine of 2 pi is 0, so we'll have negative 3 times 0, and this is telling us the slope of our equation at 2 pi is equal to 0. Now we can use y equals mx plus b, or y minus y1 equals m times x minus x1 to get the equation of the line. I like the latter, so let's use that. But if you like y equals mx plus b, you can continue to do that as well. Y minus y1, y minus 3 is equal to our slope times x minus x1, x minus 2 pi. Rearranging this, 0 times all of these things is just 0. And the equation of the tangent line to f of x equals 3 cosine x at 2 pi is just y equals 3.